started.
I think better go.
So, hope you had a wonderful long weekend. Paddy, thank you. And well done on your tests, really happy with those. I'm not going to spend long talking about them right now. I've made a video with the other class where I went through it in a bit of detail. And the reason is we've only got one lesson to get through 3A, whereas they've got two. So we're going to dedicate today's lesson to sort of working through 3A. And I'm going to post that feedback about the test on the group. Recommend that you have a watch of that video, give you some pointers and some advice about the test. But nonetheless, when I'm coming around, please ask me some questions about it. Okay? So 3A, we're doing equations of tangents. And we've done tangents before. It's just in year 12, they're going to get a little bit more complex. Now we are required to know both tangents and normals, although in the textbook I don't think there's any questions specifically about normals. Okay, so in the textbook they're focusing on tangents, but we do need to know both, and in our notes here we will explore both. So firstly, what is the tangent? Okay, so I'm going to draw the function the square root of x, okay, and what that looks like is this. Square root of x function looks like that. And if we want the tangent at x is 4, we want a line that is parallel to the curve at that point. So, we're trying to find the equation of that line, okay? It's parallel to the curve at that point. So, to find the equation of the line, we need two things. We need the POC, that's the point of contact, and we need the slope. Okay, so we want to find the equation of this line. We're talking about the tangent at x is 4, and so we need those two pieces of information. Okay, so to find the point of contact, we've got x is 4, which means the y value is going to be f of 4, which is the square root of 4, which is 2. Alright, so all you're doing to find the point of contact is putting the x value in. Sometimes you'll even be given the point of contact. So we've got the point of contact where the tangent touches the curve, x is 4, y is 2. Next we need the slope. Now in order to find the slope, this is where the calculus comes in. We know if this is the function, then f dash of x will tell us the slope for any value of x. So if this is f of x, then this is going to be the slope function, half x to the minus half. And now that tells us the slope for any value of x. So first let's simplify it, and then we can process it a bit. That's going to be 1 on top of 2 root x. Okay, now we want to know the slope when x is 4, which means we're going to put the number 4 into the slope function. So we can go for f dash of 4, there's going to be 1 on 2 root 4, which is 1 on 2 times 2, which is 1 on 4. Okay, so we've got the slope, and we've got the point of contact. We've got everything we need to find the equation of the line. Okay, so finding the point of contact, finding the slope, that's sort of the skill that we've developed in year 11 and developing now. And then all we need to do is find the equation of a line with these properties. So now you're going back to year 10. Okay, there's a number of ways we can do this. There's 3 ways in fact. We're going to go through all 3 procedures, and you can use whichever one you want. The first procedure is just an intuitive process. The equation of a line is y equals mx plus c. All right. We have a slope of 1 on 4, which means n is a quarter. All right? And then we go, when x is 4, y is 2. That's the point of contact. So let's put that information in. Oh. Okay, so just putting the point of contact in and then processing accordingly. Alright, so that, if you were to graph root x and you were to graph this line, you would see that it just touches each other, at x is 4, y is 2. All right, any questions about that one? Okay, next we are asked to find the normal at x is 9. So still the same function, but this time the normal. Now the normal, okay, if we were to draw the normal at x is 4, it's a line that's perpendicular to the curve, so it meets at 90 degrees. Now what we should remember about a normal, okay, is that if a function has slope, if a line has slope a on b, all right, then the perpendicular line is the negative reciprocal. So we flip it and we put a negative in front of it. So if we have slope a on b, then the perpendicular is going to be minus b on a. If the tangent is a on b, then the normal is going to be minus b on a. Now, we need two things again. We're finding the equation of a line. We've got the point of contact. We've got x is 9. The y value is going to be the square root of 9. So 3. Got the point of contact. We need the slope. Okay. Now we don't have to perform the differentiation because we've already done that. This is the derivative function, isn't it? 1 on 2 root x. And we want to know the slope when x is 9. X is 9, the slope is 1 on 6, all right? But that's for the tangent, okay? That is A on B. We're finding the normal, so therefore the slope of the normal is negative 6 on 1. All right, now the 1 we don't need to write. I am going to express it for now, just so you can see the link between those two. All right, so our slope is negative 6. We've got the point of contact, we've got the slope, and now we're ready to find the equation of the line. All right, so it's at this step where you can use either of the processes, right? So here we did what I just call an intuitive process. All right, Y-intercept form, finding the equation of the line. Now we're going to do it in general form. Okay, so I've got these notes written at the top of your page. But if we have slope A on B, then we can write it as AX take BY equals C. That's general form. And if we have slope minus A on B, then we can write it as AX plus BY equals C. So we've got to look at our slope, all right? And looking at our slope, if we just look here, we see it's not a fraction. That's okay. Everything's a fraction. You just put it on top of 1. All right, now which one does it resemble? Well, it's negative. So that means this is going to be the form that we use. This is the general form. So we're going to go 6x, okay, the 6 corresponds with A, 6x plus 1 lot of y. Now we don't need to write the 1, but I'm going to do it again to show you the relationship between here and here is equal to C. So we have 6x plus y is C. And now to find C, all you do is put the point of contact into this equation. We have 6 times 9 plus 3 is C. 54 plus 3, 57. Okay, that is it expressed in general form. And this can be rearranged to Y-intercept form, all right? To get it in Y-intercept form, okay, this is Y-intercept form, all you have to do is get Y by itself. This one's particularly easy to do because the Y does not have a coefficient. Minus 6x plus 57, okay? General form, Y-intercept form. Splendid. Any questions about that one? Wonderful. We'll spin this board around. Now, we're up to finding the normal. That's asked us for the normal at x is pi on 3. Okay, the normal to sine x at x is pi on 3. So this is where Year 12 gets a bit more complex. We're not just dealing with quadratics, we start to deal with trig and exponentials and logarithms and so forth. Okay, same process still applies. Let's find the point of contact. Okay, we've got the x value is pi on 3. The y value is going to be sine of pi on 3. Okay, so we can look at our unit circle, and that's going to be this coordinate here. Okay, so we have pi on 6, pi on 4, pi on 3, and the sine of that value is going to be root 3 on 2. Alright, it's really, really easy to remember the unit circle because it just repeats itself. So once you notice the patterns, you just see it. You only need to remember one quadrant, and then it just repeats itself all around. Okay, in the second one, so we've got the point of contact, now we need the slope. Okay, so if our function is sine x, then our derivative function that tells us the slope is going to be cos of x. And we want to know what is the slope when x is pi on 3. So we've got the point of contact, we've got the slope. Now that's the slope of the tangent, isn't it? Okay, that's f dash of a. So now let's use the third procedure. Okay, so we've used the intuitive process, we've used general form. Now let's use the formula. Okay, so you can see two formulas at the top there, one for a tangent and one for a normal. Now the normal is minus 1 on f dash of a times x take a plus f of a. So I've written the formula there, and just above it, I'm going to write what each part means. Okay? Now we're talking about tangent at x equals a. Alright? Now in this circumstance, we have a is pi on 3. We're talking about the tangent at pi on 3. Okay, so what we can do now is substitute pi on 3 into this formula. We've got f dash of pi on 3, x take pi on 3, plus f of pi on 3. Alright, and we've already found all of this information. Okay? F of pi on 3 is the y value when x is pi on 3. Okay, so we're going to have root 3 on 2 here. We've got x take pi on 3, that remains as x take pi on 3, that doesn't change there. And then we have minus 1 on top of the slope at pi on 3. Okay, what's our slope at pi on 3? Half. Okay? So just put the information into the formula. Okay, let's process this. We've got minus 1 divided by half, that's minus 2. And then what we're going to do is expand this. Distribute the 2. Alright, remember this is the equation of a line. It's the equation of a normal. Alright? And it doesn't look very pretty, but it's beautiful really. We've got a slope of minus 2. That's the slope of this normal. And what's this part here? Who can tell me? What's this part here? Alright, remember y equals mx plus c. That whole thing is c. That's the y-intercept, expressed in exact form. You could calculate that to a few significant figures, but here we've expressed it exactly. Okay, any questions about that one? Okay, so you can use any process you want. I've shown you 3. I just like doing the equation of the line. I think that's just the y-intercept form. I think that's the easiest. Okay, last one. 2e to the x at x equals ln(b). Alright, so we're not given a real x value, are we? We're just given ln(b). That's okay. We're just going to treat it the same. Alright, so our x coordinate is ln(b), and our y coordinate then, I'll work that out over here, is going to be 2e to the power of ln(b). 2e to the power of ln(b). Well, e to the ln(b) simplifies to b. Alright, remember e and ln are going to cancel each other. So here we've got 2b. So we have our point of contact. We've got x is ln(b), y is 2b. Next we need the slope. Consistent with our terminology. Okay, so the derivative of e to the x is just e to the x. The derivative function is no different, which means our slope when x is ln(b), so f dash of ln(b) is also 2b. Alright, so f of x, we differentiate it, it's still 2e to the x. We now want to know the slope when x is ln(b), so that's what I've done there, and that simplifies to 2b. So we've got our point of contact, we've got our slope. Okay, let's find the equation of the line with these properties. Let's use the first process, my favourite. Y equals mx plus c. We have a slope of 2b. Alright, so that means we're going to have y equals 2b times x plus c. Alright, so we input the slope, and then we input the point of contact. Okay, we're going to put 2b where the y is, and we're going to put ln(b) where the x is, and then we've got plus c. And we want to get c by itself. Alright, so I'm just going to move this over to this side. You have 2b, take 2b times ln(b) equals c. I've taken it away. Now maybe you're noticing that 2b could become a power of b. We'll leave it there for now, because we've got the value of c. So now let us state the equation of the line. Alright, it's y equals 2b times x plus c. What is our value of c? This one here. 2b, take 2b ln(b). Okay, you can see m, and you can see c. Okay, one more part. Okay, it says, given that this tangent that you found, this tangent has a slope of 4. Okay, so that means the slope m equals 4. 2b equals 4, b equals 2. Alright, that's the value of b. And now that we have a value of b, we could drastically simplify the equation of this tangent here. Alright, we would have 4x plus 4, take 4 ln(2). Splendid. So let's break for a bit. Let's get you guys to have a go at them. We're making our way through 3A. Use whatever process you're comfortable with. Let's do it.